Greetings, dear all. This is Dr. P. Saranya, Assistant Professor in PG and Research Department of Mathematics, Poweri College for Women Autonomous. In this module, we shall discuss what is an assignment problem, what is an effective method to solve an assignment problem with an example. Let's get into the module. An assignment problem is a special type of transportation problem in which the objective is to assign equal number of resources to equal number of activities in order to minimize the total assignment cost. An effective method to solve an assignment problem is the Hungarian method. The following are the steps involved in solving an assignment problem using Hungarian procedure. Step 1. Frame the cost matrix. Step 2. Row operation, that is, from each and every row, choose the least element and subtract it to all the elements of that row. Step 3. Column operation. Here, as if in row operation, find the least element in each and every column and subtract it to all the elements of that column. Step 4. Now we search for single zero row wise and then we move on to column wise. When we find a single zero, assign that zero and cross off all the zero that is lying in the corresponding row or column of that zero. Continue this procedure until all the zeros are crossed off or assigned. Step 5. Optimality condition. If all the rows have an assigned zero, then the solution is said to be optimal. Step 6. If any of the row is not at all having an assigned zero, then mark the row which do not have assigned zero. In that row, mark the column which has zero. In that column, mark the row which have assigned zeros. Now, draw the straight line on marked columns and unmarked rows. That is, strike off all the marked columns and unmarked rows. Now, from the uncovered element, that is, the element which do not lie on any of the lines is called as uncovered element. Now, from the uncovered element, choose the least element and add it to the elements in the point of intersection of the horizontal and vertical lines. Subtract that element from the uncovered elements and all the covered elements remains unchanged. Continue this process until an optimal solution is obtained. Now, the above discussed procedure is illustrated with an example. Here, the objective of the problem is to assign the programmers 1, 2, and 3 to the programs A, B, and C in order to minimize the total computer time. So, as if in the procedure, we first frame the cost matrix. Next, from the cost matrix, we move on to row operation. In row operation, we choose least element from each and every row and subtract it to all the elements of that row. In row 1, 80 is the least element, so all the elements of row 1 are subtracted from 80. In row 2, again 80 is the least element, so all the elements of row 2 are subtracted from 80. In row 3, 110 is the least element, therefore all the elements of row 3 are subtracted from 110. Now we move on to column operation. From the row reduced matrix, we have to follow the column operation. In the column 1, 0 is the least element, therefore first column remains unchanged. In column 2, 10 is the least element, therefore all the elements of column 2 is subtracted from 10. In column 3, again 0 is the least element, therefore column 3 remains unchanged. Now we move on to step 4, that is, we search for single zeros. Here, row 1 has a single zero, therefore we assign that 0. In row 2, we don't have a single zero, therefore we move on to row 3. In row 3, we have a single zero, assign that 0 and cross off the 0 that lie in that column. See, the 0 in the first column is crossed off. Now we move over to column wise. First column do not have a single zero, therefore we move on to column 2. In column 2, we have a single zero, therefore assign that 0. Now we have to check for optimality condition. Here all the rows have an assigned 0. Therefore the solution obtained is optimal. Therefore the optimal assignments are in row 1. The optimal assignment is 80. That is from the question. Now we move on to question. And in row 2, the optimal assignment is 90. And in row 3, optimal assignment is 110. Therefore, the optimal assignments are 1 is assigned to C, 2 is assigned to B, and 3 is assigned to A. And the optimal assignment cost is 80 plus 90 plus 110 equal to 280. Hope this module has given you an overview of what is an assignment problem, how shall we solve an assignment problem using Hungarian method. Thank you. Have a nice day.